our water rate, which is given previously, 1,000 gallons per minute, all over 576 feet squared. 500 there is just a conversion factor to convert the unit gallons per minute to pounds per hour. Then air loading is just, so our fan just equal to the fan capacity multiplied by our density, which is the reciprocal of our specific volume, multiplied by our conversion factor. Conversion factor here is to convert the minute for the cubic feet per minute into hour, all over the ground area, which is 576 feet squared. Then dividing the answer for L and G, we will get our ratio, which is equal to 0.866. So next is for the computation of our H2 or enthalpy at various temperatures. We will consider here temperatures at a range of 80 to 100, which is 80 is our cold water temperature and 100 is our hot water temperature. So this will be constant, our H1. Enthalpy, saturation enthalpy at 65 degrees Fahrenheit, L over G, which is obtained previously, 0.862, and T1 minus T2. T2 here will be constant with 80 degrees Fahrenheit. We will just vary T1, which is 100, which is 80 to 100 to get our H value or enthalpy value for the equation for our T over L. So here we will get 47.7. So our final equation will be KAV over L equals the integral form of dt over h prime minus h. So we will consider our range of 80 to 100. Since in our air-water vapor mixture table, there is 5 degree interval, so we consider here 80, 85, 90, 95, and 100. H prime here are just literature values that we can get from our steam table or even from our air-water vapor mixture table previously been viewed. Then we will get the H here from the equation H2 equals H1 plus L over G T minus 80 degrees Fahrenheit. So we just vary the temperature T2 there and we will get these values. So we have to subtract H prime with H to get this one. Then we will have these values and average the first two values consecutively to get H prime minus H average. Then we have to use these equations in our equation by getting dt, which is just 5 degrees since our interval is 5. So here is 5 all over H prime minus H average, which is here. And then we will get these values. So by integration, we will just add these values to get our KAV over L. So we will get 1.125 for our power characteristics by numerical integration. And from this graph, we will just notice that it is just the graphical representation of the table from the previous slide, which is from here, the operating line serves as our H versus T data. H here is obtained from the equation H2 equals H1 plus L over G multiplied by T minus 80 degrees Fahrenheit. And our equilibrium line here is get from the literature values of H at the range 80 to 100 versus the temperature. For the Chebyshev method here is...
Now we're going to use the Chebyshev method to calculate the power characteristics of the. So basically, the Chebyshev rule method is equation type method. So this is the equation is equal to the T hat minus over 4, then the enthalpy differences of the CoolingTower. So the variables is revenue. So HW is the enthalpy of air water vapor mixture at hot water temperature. Then HA is the enthalpy of air water vapor mixture at hot water temperature. Then H1 delta H1, delta H2, delta H2, delta H4 is the enthalpy differences at temperature 2 plus 0.1 times T1 minus T2. So this is the calculated values for the following variables. So then planning in the equation, dun sa first equation, kuha tayo ng characteristic value na KE over L value na 1.11. So for the
So, yung last na pag-aaralan natin ng paraan ng pag-solve sa cooling tower sa nomograph method. So, bali, yung nomograph method siya yung pinakamadaling method na gamitin kasi gamit ka lang ng tables. Tapos, ipaplat mo lang yung values na given sets, makukuha mo rin yung mga kailangan mong value. So, yung dalawang numerical method sa grammatic kanina, ginawa lang natin siya para compare natin yung mga sagot sa kanya. So, di ba yung sa una, integration method tayo, ano ka natin na answer is 0.1125. Tapos yung sa chef method naman, 1.111. So, magkalapit sila. So, dito, titingnan natin kung yung sa nomograph method, ikaw parang sagot sa atin ng dalawa. So, edit yung given sa atin. Meron kang wet bulb temperature 65 degrees Fahrenheit, cooling range na 20 degree Fahrenheit, cold water temperature na 80 degree Fahrenheit, tsaka LOVG ratio na 0.8662. So, yung paggamit ko sa nomograph, so yung una, ipag-given tayo ng cooling range tapos cold water temperature. So, gagawin natin, magagawa tayo, tapos given tayo ng wet bulb temperature natin mula doon. So, gagawin mo, magagawa ka ng line na magpapass through doon sa given na wet bulb temperature, cold water temperature, saka yung cooling range. So, yun yung line dito sa baba na may kulay ko ng gas. Tapos, after nun, di ba may given sa atin na LOVG ratio. So, para makuha mo yung KAV over L, magagawa ka ng line na parallel dito mula dun sa given na LOVG ratio papunta dun sa KAV over L line dito. So, mula dun sa method na yun, na makuha mo na KAV over L ay 1.112. Tapos, sunod naman, sa pangalawang graph naman, dito pwede mo makuha yung water concentration na gagamitin mo dun sa cooling tower mo. So, ang given natin dito yung parang problem pa rin. So, dito naman, given tayo ng cold water temperature, tapos wet bulb, hindi na given yung hot water dito sa specify. Pero, gagawin mo lang, magagawa ka ng line na magkakonect sa mga given sa'yo. So, dito, itong given sa atin, may 80 degree Fahrenheit ka na cold water temperature, tapos 65 degree Fahrenheit sa wet bulb temperature. So, pag didikinin mo lang siya, tapos yung point ko sa siya magtatapat, yun na yung magiging water concentration mo. So, mula doon, ang mga water concentration is 3 gallons per minute feet square. Tapos, yung last naman, dito, yung pagkuha ng horsepower requirement. So, ito, given the same problem, tapos, kung per square, yung natin yung power requirement per square foot ng tower area. So, given ang tower area is nag-ooperate ang 100%. So, ang gagawin mo lang, hanapin mo dito sa graph, dito sa curve na to, yung percent of standard tower performance mo, which is 100. Tapos magagawa ka ng line, papunta dun sa horsepower per square area of tower area na na values dito, na magpapasok sa turning point. So, dito yung line na yun, kasi makuha mong horsepower per square feet of tower area is 0.04. So, kung gusto mo naman yung total horsepower requirement ng mismong cooling tower mo, yung multiply mo yung complete yung value dun sa tower area mo kanina. Tapos, hindi yun. Yung references na. Bali yun lang yung sa cooling tower.